This is Friday's lesson, a continuation of 4.3, dividing polynomials. So first, let's take a second, pause this video, and take some time to divide using long division here. So first, we notice that our dividend is here, so that's what's going to go under the divisor sign, so negative x cubed plus 4x squared. Now notice that we don't have an x term, so we need to put a placeholder there, 0x, and then plus 9. Now we are dividing that by x minus 3. So what do we multiply x by to get negative x cubed? Well, we know it's x squared, right? X squared times x gives us x cubed, and we need it negative, so it's going to be a negative. We get negative x cubed. And then negative x squared times negative 3 gives us positive 3x squared. We subtract that. This is 0, and we have 4x squared minus 3x squared gives us x squared. We bring down our 0x. Now I need to get to x squared. So x times x gives me x squared. So I'm going to add x. X squared, and then x times negative 3 gives me negative 3x. Okay, so now I need to subtract here, sorry. Those are 0, and here, remember to distribute that negative, so I'm positive 3x. So how do I get from x to 3x? I need to add 3 because 3 times x gives me 3x. Oh, and I forgot to bring down my 9 here, so I should have plus 9. And then 3 times negative 3 gives me negative 9. Again, I'm going to subtract, so that would be 0. And then I have 9 plus 9 gives me 18. And 18 now is my remainder. So I can plus 18. And remember that we put 18 over our divisor. X minus 3. Here's my answer. Perfect. So today we're going to continue dividing polynomials, but we're going to look at using synthetic division to divide polynomials. Now, in order to use synthetic division, our divisor has to be in the form of x minus k. So like we saw here, we had x minus 3, which it could also be x. Like x plus 3, x minus 5, x minus 7, x plus 14, all of those would work. But our divisor has to be a binomial, that's called. So let's take a look at how synthetic division works. So we're going to set it up looking at only the coefficients. So if I look at the coefficients of my dividend here, they are negative 1, right? There's a 1 in front of that x, 4, and 9. And notice I'm missing my x term. Again, this is the same problem that we just did in the opening activity. So we're again going to have a placeholder. So I'm going to write out my coefficients. I have negative 1, 4, and then remember there's a 0 on that x term, so 0 and 9. Now I'm going to do, it's like an upside down divisor sign. And I need to solve for x here. So this would be x equals 3. I'm going to put that 3 right there. Okay, so first thing, I bring down my very first term. Negative 1, I bring that down here. Now I take negative 1 times 3 and put that under my 4. So I have negative 1 times 3, which is negative 3. And now the difference here, instead of subtracting, I'm going to add. So I have 4 plus negative 3 gives me 1. So then I do the same process. I take 1 times 3, which gives me 3, and I add. Now I take 3 times 3, which gives me 9, and again I add 18. So this was x cubed here, and x squared, x, and then our constant term. So our answer, or this is called our quotient, is going to go down a degree by 1. So instead of our answer having x cubed is going to be start with x squared. So the answer here is negative x squared plus x, right, because the coefficient there is 1, plus 3, and then this here is my remainder. Okay, so remember this, my remainder goes over, same concept, over my divisor. So my remainder here is plus 18 over, this originally was x minus 3. So notice this is the same exact problem that we did in our opener, done using synthetic division. So let's try this one. Here we see all of our terms are there, so we won't need any placeholders. We have x to the 4th, x to the 3rd, x squared, x, and a constant term. So go ahead and write our constants. If you feel comfortable, I would suggest pausing the video here and trying this one on your own. So I'm going to head and write my coefficients. I have 1, negative 5, negative 8, 13, negative 12. And then x minus 6, so this would be 6, right? Because x equals 6 here. If I set that equal to 0, now I'm going to bring down my first term, multiply, and then I add these. Negative 5 plus 6 gives me positive 1. 1 times 6 is 6. Negative 8 plus 6 is negative 2. Negative 2 times 6 gives me negative 12. 13 plus negative 12 is 1. 1 times 6 is 6. Negative 12 plus 6 is negative 6. So this is my remainder. And again, so this was an x to the 4th degree, so a degree 4 polynomial. So this is going to be a degree 3 polynomial. So I start with my x cubed. Now remember, this is my remainder, so I have negative 6 over x minus 6. Perfect. Now again, if you feel confident, go ahead and pause the video before I go through this last one and try it on your own. So we notice that we go from x cubed to x to our constant term, so we're missing that x squared term, so be careful and make sure we put a placeholder in there. So we have 2, and our placeholder for x squared would be 0, negative 1, negative 7. Oop. Leave a little room there. Here we have x plus 3. If we set that equal to 0, we get negative 3. Bring down our first. 2 times negative 3 is negative 6, and I add negative 6 times negative 3 is 18. So I add, I get 17. And 17 times 3 is 51, I believe. Yep, so I have negative 51. And I get negative 58. And remember, this is my remainder. We started with a degree 3 polynomial, so our answer is going to be a degree 2 polynomial. So we have 2x squared minus 6x plus 17, and then plus negative 58 over x plus 3. So in my opinion, synthetic division is a little bit faster. And I think it's easier, but again, you can do any of these using long division would work as well. So with synthetic division, we can evaluate functions. So this is the remainder theorem, and it states if a polynomial f of x is divided by x minus k, then the remainder is f of k. So that's kind of hard to understand. So we can use synthetic division to evaluate a function at a given value. So here, if they ask us to evaluate f of x when x equals -4, a lot of times we're used to just plugging in -4 wherever we see an x and solving. And that totally works, absolutely. But another way to do that is using synthetic division. So here you notice x is already solved. So we put that -4 as our divisor. We write out the coefficients of our function here, go through the synthetic division process, and here, whatever our remainder is, remember this is our remainder, that is that function evaluated at the given x value. So this function, f of x equals 5x cubed minus x squared plus 13x plus 29, when x equals -4 is -359. So let's go ahead and use substitution to check that, to see how this works. So we would have f of x equals 5 times -4 to the third minus -4 squared plus 13 times -4 plus 29. So I'm going to go ahead and plug that into my calculator. Be careful with our signs. Make sure we're using parentheses where appropriate. Minus -4 squared plus 13 times -4 plus 29. And I do get -359 if make sure we did all of our parentheses correctly. So let's practice this. Use synthetic division to evaluate, then check using substitution. So we're going to go ahead, set this up as if we were set this up in synthetic division. So again, I look at my coefficients, which are 1, -6, 9, -8, and 18. So I notice that all of our terms are there from 4 to 0. And then they already solved here, x equals 2. So I'm going to go ahead and put a 2 there, bring down my 1. 1 times 2 is 2. I add, I get -4. -4 times 2 is -8. I add, I get -1. -1 times 2 is -2. I add, I get -10. Oh, I made a mistake. I'm sorry. This should be +1, right? 9 plus -8 is +1. 1 times 2, that makes that a +2. -8 plus 2 gives me -6. -6 times 2 gives me -12. 18 plus -12 is 6. So if we did all this correctly, f of x, this function here at x equals 2 should be 6. So I'm going to go ahead, plug 2 in for x into my calculator, and if we did all this correctly, it would be 6. So 2 to the 4th minus 6 times 2 to the 3rd plus 9 times 2 squared minus 8 times 2 plus 18. And I do indeed get 6. So I honestly think in this situation as well, synthetic division is again faster, and I'm going to do less errors than I probably would punching into my calculator. So go ahead and do this last one, pause the video, and do this one on your own before we go through it here. So my coefficients, I look at my degrees, I go 3, 2, 1, 0, perfect. So I don't need any placeholders. I have -1, -10, -24, and 4. That would be -4. I bring down my -1. -1 times -4 is +4. Gives me -6. I'm adding, remember. 24, I get 0. 0 times -4 is 0, so I get a remainder of 4 here. So again, if you plug this into your calculator, go ahead and check it, and you do indeed get 4. For our last problem of the day, we're just going to go ahead and review revenue problem. This was good for us. So pause this video and try and do this on your own, and then come back and check. So we remember that revenue equals our items times the cost. So in this case, our items are riders riding the city bus. So we can go ahead and we look for 24,800 riders is our original amount, and then it will increase by 400 people per price increase, right? Or decrease. So plus 400x. And I'm going to go through and find my cost, which it originally is $1.85. And we're looking at a 10-cent decrease. Okay, now I'm going to go through, remember, once we get this set up, we set those equal to 0. Okay, and then I'm going to solve for x. And then same thing here. Now remember, these are our x-intercepts, and we are looking to maximize revenue. Remember, when we're looking to maximize something, we're looking at the vertex. So if these are our x-intercepts, our vertex is going to be in the middle of those, right? So we need to take the average, or p plus q over 2. And go ahead and plug that in. We get negative 21.75. So this is something we're not used to, is seeing this as a negative, because x stands for the number of price. In this case, they were decreasing price. So if we think about, what does that negative value mean? We're decreasing the price negative 21 times. Well, if we think about it, that means we are increasing the price, right? We're going to increase 21.75 times. So it would be most beneficial to not do price decreases and gain people, but rather increase the price, and we take the risk of losing some people. So now this question was asking for what fare or what price will produce the maximum revenue. So we're going to go ahead and plug that x into our cost. So we get 185 minus 0.1 times negative 21.75. And we get 4.025. But since we're working with money, we're going to round to the nearest hundredth, right? The nearest cent. And that would be $4.03. Okay, that's all we have for today's lesson. So now you should complete the synthetic division worksheet, which is posted on Schoology, and complete the synthetic division formative. And as always, reach out if you have any questions. Have a great day.